We've covered RAM as a form of short-term storage or volatile memory. That is, it is usable when there's power, but when there's no power, RAM is empty because it has no power feeding the bit line to charge the capacitors. Disk drives, on the other hand, are longer-term storage components. Anything that your computer isn't currently using but is stored for retrieval will be in disk storage, written on the disk drive. We will generically refer to any longer-term, non-volatile memory collectively as storage. This is also the secondary memory category of a computer, as opposed to RAM, which is primary memory. When we say long-term storage, we mean essentially permanent storage. Disk drives can be unplugged and moved around, and they'll still contain the same information as when they're plugged in. Information is copied from disks to primary memory when it's needed, and then it's manipulated in that primary memory before possibly being written back to disk. Storage is much slower than RAM, but that also makes it cheaper. As a result, for the same budget, you can get much more capacity in storage, which is usually measured in terabytes, than you could in RAM, which is usually measured in gigabytes. But in the world of HPC, we are not really in the business of data storage. We're much more interested in performance. The original hard disk drives, or HDDs, are much older magnetic technologies. They contain a series of platters covered by a ferromagnetic coating with the direction of the magnetization representing the individual bits. Data is written and read by a head, similar to the old-school vinyl records that your grandparents or your parents used to use. This older technology is all mechanical, so it is the slowest component of any computer, and because it's magnetic and mechanical, it's also the most fragile. The SSD is a newer technology disk that uses flash memory and is non-mechanical. This means that they are also shock-resistant and much more resilient in general. SSDs are extremely fast when compared to HDDs. There's always going to be a trade-off when designing an HPC system between storage capacity and storage performance, and it's important to understand where the SSD really outstrips the HDD. Copying and moving huge files, such as movies, is a sequential operation where hard disk drives perform up to 150 megabytes per second, and SSDs up to 500 megabytes per second, with the new NVMe SSDs going up to 3,500 megabytes per second. Small 4K read-write operations reflect smaller files, which are much more common with typical interactive user operations like browsing the internet. Here, the hard disk drives perform up to 1.7 megabytes per second, and SSDs up to 250 megabytes per second. So the performance contrast between HDD and SSD should be obvious enough that whenever possible, SSDs would be preferable. Right? Not so fast! There are several SSD connector types that SSDs use to interface with the computer, and the most common consumer options are SATA and M.2 SATA. These are capped at a maximum theoretical transfer speed of 600 megabytes per second, whereas newer interfaces exceed 3 gigabytes per second. So sometimes the performance gain for the price pain of choosing SSD instead of HDD might not be as good as you'd expect or you'd hope for. Non-volatile memory express, or NVMe, is a new controller used to replace the older Advanced Host Controller Interface, or AHCI. AHCI as a controller proves to be a bottleneck for SSDs, since it was never actually intended to cater for non-platter type disks. NVMe controllers, on the other hand, were built specifically with SSDs in mind, bypassing the SATA bus and taking advantage of the PCI Express as a bus. Finally, M.2 drives with an M and a B key, that is 6 pins, are SATA-based SSDs, so they will be significantly slower than the single M key drives which are NVMe. When shopping for a disk drive, you'll consider 3 main pieces of information: the disk capacity, the disk interface, and its size. HDDs come in 3.5-inch and 2.5-inch form factors, which will also influence compatibility with your chosen chassis. It is possible to fit a 2.5-inch or a 3.5-inch disk in a tower chassis, but it's unlikely to find a rack-mounted chassis that supports 3.5-inch disks. You might also be presented with hybrid disks, which are a middle ground between purely solid-state disks and the older magnetic or mechanical disks. These essentially use some level of flash memory on top of the magnetic or mechanical disk technology. A recent inclusion in Dell systems is the BOS card, which is an acronym for Boot Optimized Storage Solution. This is a technical solution by Dell to free up usable disk space on the chassis and separate the OS drives from the data drives. They use RAID-intensive M.2 SATA SSDs for pass-through or RAID 1, and RAID will be covered in a later chapter. One of the attractive features of a BOS card is that they free up available disk bays on a chassis so you can focus on using them for storage rather than your operating system, which is typically a smaller disk drive.